Hey guys, welcome again to another time with the Maths Club. So we're continuing on our series on fractions, decimals, and approximations, but we'll be looking at LCM and HCF today. LCM and HCF is very important for us to be able to carry out basic operations in fractions, such as addition and subtraction mostly. Right. So before we begin, I would like to say that if you've been following our content and you find the channel useful, kindly subscribe to our channel and spread the word. If you know somebody that would benefit from this particular channel, invite them to partake of the things that we do. So let's get started. So the first thing that we're talking about, when you hear HCF, HCF is highest common factor, right? And LCM is least common multiple. But you're hearing the word factor, hearing the word multiple. What do they mean, right? So let me start from an instance. If I have a number 12 and I want to find all the things that I can multiply that will give me 12, right? So I will know 1 and 12, right? 2 and 6, right? 3 and 4, right? If I say 4 and 3, it's like repeating myself with this 3 and 4. So whenever I get to a point where I repeat myself, I will stop, right? So when I break down all the things that can give me 12, like this 1 and 12, 2 and 6, 3 and 4, all of these individual values, they are all factors, right? So 1 is a factor of 12, 12 is a factor of 12, 2 is a factor of 12, 6 is a factor of 12, and so on and so forth. So that means that the highest factor of a number, right, is actually that number itself, right? Because look at it, I have 12 and the highest factor is 12, because 12 times 1 would give me that number. So if I say the highest factor of a number is 12, that means the lowest factor of a number is what? Great, is 1, right? Is 1. So all these individual numbers, like any number that you can multiply with another number that can give you that particular value back, like 12, all those individual numbers are all factors. So let's see what we have in our notes. So it says factors are numbers that we can multiply together to get another number, right? So look at this. So we have 2 times 3 is equal to 6. You can see 2 is a factor of 6 and 3 is a factor of 6. Fine. Great. So let's look at multiple. In your times table, right, so say 5 times 1, 5. 5 times 2, 10. 5 times 3, 15, and so on, right? So if you look at it, if I want to find the multiples of 5, for instance, so if I wanted to find the multiples of 5, I'll say 5 times 1, 5. 5 times 2, 10. 5 times 3, 15, right? So things like that. So 5, 10, 15, 20, and on like that. They're all multiples of 5, right? So any number that, so if you have 5 times 1, 5, like any number that you can get with that kind of thing, they will all be multiples of the particular number you're dealing with, right? So let's see what the note is actually saying. So it says the result of multiplying a number by an integer, right? So what we get will be a multiple. So if I have a number 5 and I'm multiplying by an integer, first time 1, second time 2, third time 3, the result is going to be a multiple, right? And remember the integer, right? Integer, not by a fraction. Note that. So an example is 12 is a multiple of 3, right? Because 3 times 4 is equal to 12. I hope you've been able to know the distinction between factors and multiples. So in this case here, 12 is a multiple of 3, right? If I wanted to find the factors of 12, in this case here, what are the factors of 12? And from what we have on this place here, can you pin it out? Great. 3 is a factor of 12 and 4 is also a factor of 12. Great. So let's continue. So now let's go to the least common multiple, right? So LCM stands for the least common multiple, like we said. And they said it's a mathematical concept used to find the smallest multiple that is divisible by 2 or more numbers. So let's look at that. So if I wanted to find what is the LCM between 5 and 12, right? LCM, remember, LCM is talking about multiples, so I have to list out all the multiples of 5. So 5, 20, let me say 25, let me say 30, right? Let me also list out the multiples of 12. So that will be 12 times 1, times 2, times 3, times 4, which is 48, times 5, which is 60, right? So if you look at it, have I found a match between these two? No, I've not found a match, so I'll keep on moving. Let me keep on moving. So this one here is 35. We have 40. We have 45. We have 50, 55, 60, right? So you can see, look at how far I had to go before I found a value that is a common multiple between the two of them, right? So the least common multiple between our numbers 5 and numbers 12 is actually 60, right? So by the time I look at the comparison of it, so the LCM in this guy is actually 60, right? So you can see that it's actually a very long thing for me to be listing all of these things individually. Fortunately for us, there are methods that we can actually use to find these things, right? And I'll look at that shortly. Now, what is HCF? HCF, right? We're talking about factor, right? HCF is just the highest common factor, right? And also known as the greatest common divisor, right? Greatest common divisor. That is, it's a mathematical concept used to find the largest positive numbers or largest positive integer that divides two or more numbers without leaving a remainder. So if I have a number, like if I have something, let's say I have 15, let's use our 12 and 5 example. We have 12 and 5, right? So I'm looking for a number that would be able to, the least common number that would be able to divide 12 and 5. So every number would have at least one common factor, right? What's the common factor? That is 1, right? 1. Because you say 12 by 1, 5 by 1. So let's look at 12. But let's break this down to the factors. That would be 1 and 12. That would be 2 and 6, 3 and 4. Right? If I say 4 and 3, again, that's repeating myself. So what of 5? Right? The only thing that gave me 5 is 1 and 5. So what's common in two of them? Because the only thing that's common, the only factor that's common here is what? Is 1. Right? So that is the highest common factor between these two numbers. Right? So at least, right, as the worst case scenario, the highest common factor will always be 1 in cases where there is nothing really joining those two guys. But if I had something like 12 and let's say 36, right? So for 12, I'll have 1 and 12, 2 and 6, 3 and 4, right? And then for 36, I can have what? 1 and 36, 2 and 18, right? 3 and what? 3 times 12 will give me 36. 4 times what? 4 times 9 will give me 36. 5, 6 times what? 6 times 6. Right? So once I reach a repetition, like if I have 6 and 6, I will know that I will stop. So there are two places where I know I will stop. If I'm going to repeat myself like this 4 and 3, or if I get the same values, then I know I will stop. So let's look at the factors. The highest factor. So for me to find the highest factor, I'll go to the smaller number and find the highest factor. The highest factor here is 12. And I'll look at this place. Is there 12 here? Yes, there's a 12 here. So that means that 12 is the highest common factor. So the highest common factor is equal to 12 because it's present here and it's present here, right? So you have to look at what is actually present in this. And you can see 12 will divide this 12 conveniently and to divide this 36 conveniently, right? So that is what we mean when we say highest common factor. So it's a mathematical concept just to find the largest positive integer that divides two or more numbers without leaving a remainder. So that's basically about the HCF. So look at this thing now. So once you find the HCF between 24 and 36, I think I've already done that. Okay, no. So this is 12 and 36. So if I wanted to do 24, so 24, I'll say 1, 24, 2, 12, 3, 8, 4, 6, 4 times 6 will give me 24, then 6, 4. That is repeating myself, so I won't do that, right? So this is 24 and 36. So the highest factor here is 24. I'll look at, is there 24 here? No, there's no 24. I'll look for the next highest, which is 12. Is there 12 here? Yes, there's 12. So that means that my HCF between 24 and 36 is what? Is 12, right? Now, what of the LCM? If I wanted to find the LCM, what am I going to do? Which is the lowest common multiple, right? The lowest common multiple. That is a bit different from what we're doing, right? Also, before we even enter the LCM, there is another way of actually solving the HCF because you might not have the luxury of listing everything out like this. It could be very large numbers. I could be like maybe 1,346, right? Before you start listing all of the things out, it could be a while. So there's another method that we could use, right? And that's what we're going to go to now. So in this particular method, right, what do? We use the prime factorization. We want to find the prime factorization, right? I know we've not reached prime numbers, but take it like that. So here we have 24, right? And we have 36. So I'll divide 2 in 24 is 12. 2 in 12 is 6. 2 in 6 is 3, right? 3 in 3 is 1. Great. I'll come here again. 2 in 36 is 18. 2 in 18 is 9. 3 in 9 is 3. 3 in 3 is 1. The reason why I'm switching from 3, so once I switched to 3 here because there was no value that would divide 9 again. The next that would divide 9 was 3. That's why I moved to number 3. So if I break this down, right? So 24, for 24, I had what? I had 2 times 2 times 2 times 3, Abby? And then for 36, I had what? 2 times 2 times 3 times 3, right? So if I wanted to find the highest common factor, right? So you can see 2 of them actually have 2. There is a 2 here, so I will join this 2, right? This 2 also have this 2. I will join this 2. This one has 2, but there's no other 2 here, so it's not, the other 2 is not common to both of them, right? So what else is common? There's a 3 here, but there's no 3 here, but there's a 3 and 3 here, so this 3 is common. So I'll put it here. So what is the HCF between these two guys? I'll take one of this, which is 2, one of this, which is 2, one of this, which is 3. So that would be 2 times 2 times 3, right? So 2 times 2 is 4. 4 times 3 is 12, right? So this is a good way to actually find the HCF, right? Now, what of the LCM, right? The LCM, which is the lowest common multiple between the two of them. So what is the lowest thing, right? That by the time I'm doing multiples of 24 and multiples of 36, right, it will be the lowest. So let's do it in terms of listing, the way I did this previous guy. So let's do it in terms of listing. So I have 24 and I have 36. I'm trying to find the lowest common multiple. So I said, multiple is 24 times 1, which is 24, times 2, 48, times 3, which is 72. Abi? Let's also find the multiple of 36. 36 times 1 is 36, times 2 is 72. Have we found the match? Yes, we found the match. Where is the match? The match is what? 72. So in this case, the lowest common multiple is 72. Right, so you can see the bit of the tweaking. When I was doing the highest common factor, I split this into things that can multiply and give me the value. When I was doing the multiple, I was doing like times 1, times 2, times 3, till I found a match between the two of them. And like I said, in this previous one, it could get very, very long, right? You could be dealing with very large numbers. So this method might be good for very small numbers, but when the numbers become very large, it is no longer effective, right? So how can we be able to get the LCM from this, right? So in this 24, right, how many 2's do we have here? We have 3 2's, right? And in 36, how many 2's do we have here? We have 2 2's, right? So for LCM, right, LCM, in HCF, we're grouping 2 of them, grouping. But for LCM, you look at the one with the highest number of 2's or of each number. So we have only 2's and 3's inside this place. So for the 2's, you have to look for which one has the highest number of 2's. Is it 24? Or is it 36? So obviously it's 24, right? So we'll pick the one with the highest number of 2's, right? So how many 2's are there? We have 3 2's. So that will be 2 times 2 times 2. And this one, the next number is 3. So which one has the highest number of 3's? 36, right? So we'll pick the one with the highest number of 3's and we'll multiply it. So that will be times what? Times 3 and times 3, right? So this is basically it. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. 24 times 3 is what? 72, right? So if I backtrack, for LCM, right, we group them together. We could say, for HCF, we group them together. I could group them together and say, this is common, this is common, this is common, right? And then I'll multiply 2 times 2 times 2, right? But for LCM, right, I'll look at my expression and look at, for each of the values that are represented, which one has the highest number. So this one is 2, there are 3 2's. I'll put the 3 2's times, what is the highest number of the next number, which is 3? I'll pick the 2 of them and multiply together, and then I'll multiply all of the values and that'll give me the LCM, right? So if it's still a bit strange, let's go to the next example and you'll see it better. So in this, yeah, so we had 72, that's correct. So in this next example, we're trying to find the HCF of 6, 12, and 18, right? So let's see. So this is 6, this is 12, and this is 18, right? So 2 in 6 is 3, 3 in 3 is 1, right? 2 in 12 is 6, 2 in 6 is 3, right? And 3 in 3 is 1, right? 2 in 18 is 9, 3 in 9 is 3, 3 in 3 is 1, right? So for 6, what do we have? We have 2 times 3, right? 2 times 3, give me 6. And for 12, I have what? 2 times 2 times 3. So 2 times 2 times 3, right? For 18, what do I have? I have 2 times 3 times 3. Right, so the question says I should find the HCF, right? So the HCF. So like I said, you find, so we have to find what is common on all of them. So there is 2 common in all of them. So I'll group all the 2's together, right? And then there's 3 common in all of them. So I'll group these 3 together, right? So what is common in both of them? We have a 2 and we have a 3. So 2 times 3 is what? 6, right? So that is basically the HCF. Very simple. Great. The next question is that we should find the LCM of this particular thing. So for the LCM here, right, this one has 1, 2. This one has 2 2's. This one has 1 2. So we'll pick the one with the highest number of 2's, right? So the highest number of 2's is 2 2's. So that will be 2 times 2 times the one with the 3. This one has 1 3. This one has 1 3. This one has 2 3. So we'll pick the highest number of 3's, right? We have to pick the highest number. So that will be times 3 times 3. We're picking the highest numbers to ensure that all of these numbers, like the multiple that we'll be picking, will be multiple that will be convenient with the one with the highest numbers. Do you get? Like, we just want to ensure that whatever number we're picking, all of this number, it will be able to be divided by this 6, this 12, and this 18, right? That is really the essence of picking the highest 2's, right? And the highest 3's or the highest 5, as the case may be. So 2 times 2 is 4, 4 times 3 is 12, 12 times 3 is what? Is 36. So that means the least common multiple, right, of this guy is actually 36. Let's see if we're correct. Great, we're correct. The last 2 examples, right, I would like you to actually try it out by yourself. So let's see. Find the HCF of 48 and 60. You can pause the video and try it out yourself. Welcome back. Right, so let's solve it together. So we want to find the HCF of 48 and 60. So we have 48 here and we have 60 here. So let's do the division. 2, this is 24. 2, this is 12. 2, this is 6. 2, this is 3. Then we move to 3, this is 1. Right? 2, this is what? 30. 2, this is what? 15. 3, this is what? 5. 5, this is what? 1. Right? So for 48, we add, if I look at all these things here, we have 2 times 2 times 2 times 2, then times 3. And then for 60, we add what? 2 times 2 times 3 times 5, right? So if I wanted to find the HCF, I'll just find what is common. This is common, right? Then there's a 3 that is common, right? So this is common. That's the only thing that's common. So the HCF here is 2 times 3. So that means the HCF is 6. Is that correct? Oh, sorry. We missed out something. So this is 2. This is 3. Also, there are also 2's that are common. Yeah, my bad. So multiply this by 2 also. So this will be 6 times 2. And this is what? This is 12, right? Yeah, thank you for spotting that. So this is 2. This is another 2. And then 3, right? So the HCF is actually 12. Great. We're doing great. So if we wanted to find the LCM, right? Even though the question is we should find the LCM, right? So pause the video and try to find the LCM. Welcome back, right? So what is the highest value of? We have 2, we have 3, we have 5. Which one has the highest value of 2? 48. We have 4 of the 2, so that would be 2 times 2 times 2 times 2, right? Multiplied by the 3. How many 3's do we have? We have 1 3, we have 1 3 here, so there's only 1 3, right? and 5. How many 5 do we have? We have only one 5, right? So that will be times 5, right? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16, right? 16 times 3 is 48, right? And 48 times 5, that is what? 200 and what? And 40. So now that is that about that particular question. So this last question is saying that we should find the LCM of 15, 24, and 60. Right? So I want to pause the video and try it out yourself. Welcome back. So let's look at it together. We have 15, we have 24, and 60. Right? So 3 in 15 is 5, 5 in 5 is 1, 2 in 24 is 12, 2 in 12 is 6, 2 in 6 is 3, 3 in 3 is 1, right? So for 60, 2 in 60 is 30, 2 in 30 is 15, right? So 3 in 15 is 5, 5 in 15 is 1, right? So for 15, what do we have? We have 3 times 5. For 24, what do we have? We have 2 times 2 times 2 times 3, right? And then for 60, what do we have? We have 2 times 2 times 3 times 5, right? So if we wanted to find, what did you say we should find? The LCM. So the LCM. So for the LCM, look at what is common. So we have 2, we have 3, we have 5. Which one has the highest number of 3s? 24. That is 3. Sorry, which one has the highest number of 2s? 24, which is 3 2s. So that would be 2 times 2 times 2 times, which one has the highest number of 3s? They all have 1 3 3. So that's times 1 3. And they all have, this one has 1 5, this one has 1 5. So the highest number of 5 is 1, right? 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. 24 times 5, 120, right? 24 times 5 is 120. So let's see. Great. So that's the LCM. So if you got this, you actually did very well. As a bonus question, let's look at the HCF. Pause the video again and try the HCF by yourself. Welcome back. Right, so we also that the only thing that is common in 3 of them is one appearance of what? One appearance of 3, right? That's the only thing that's common in both of them. So the HCF is actually 3, right? It's actually 3. So let me also say something, that there are times where you might not find anything in all of them, but remember that you can multiply by 1, you can multiply by 1, you can multiply by 1, right? So if there is nothing that matches in any of them, the HCF in that case would be 1. Does that make sense? Great. So with this, we've actually come to the end of LCM and HCF. In the next video, we'll be applying the LCM more importantly. I think it's going to be the LCM more, right? When we're doing the addition and subtraction. See you guys in the next video.